Hello students, my name is Surya Prakash Pandey and today we are going to learn how to identify odd and even function. So basically a function is said to be an even function if f of negative x is equals to fx for all x negative x belongs to domain of f. Please remember all even functions are symmetric about y-axis. Here I have drawn a even function y equals to x square. Let us see a couple of example of even function. Here, f of x equals to x square mod x cos x. They are even function. And x sin x is also even function because this is simply product of two odd functions. Let us see what is odd function. We say a function is a odd function if f of minus x equals to minus of fx for all x and negative x belongs to domain of f. Please remember, odd functions are symmetric in diagonally opposite quadrant. And simplest example of odd function is simply y equals to x. We can see that it is symmetric about diagonally opposite quadrant. Here are some examples of odd function like fx equals to x or fx equals to x raised to the power any odd power or sin x, tan x. They are all example of odd function and we can easily prove that they are odd. For example, suppose we want to prove fx equal to sin x is an odd function. So put f of minus x. So since fx is sin x, so f of negative x is simply sine of negative x, which is equal to negative sin x, and this can be rewritten as negative fx. So fx equal to sin x is simply a odd function. Similarly, we can easily show that all these functions are odd functions. Let us see a couple of questions also. Here we have four functions and we have to identify which of the following functions are odd, even, or neither odd nor even. So take the first example. Here fx equals to x times of a raised to the power x minus 1 upon a raised to the power x plus 1. Put negative x in place of x, we get negative x into a raised to the power negative x minus 1 upon a raised to the power negative x plus 1. This can be rewritten as negative x into 1 upon a raised to the power x minus 1 upon 1 upon a raised to the power x plus 1. Let us solve this. So f of negative x equals to negative x into 1 minus a raised to the power x upon 1 plus a raised to the power x. Multiply negative sign within the bracket, we get x into a raised to the power x minus 1 upon 1 plus a raised to the power x or a raised to the power x plus 1. And this is nothing but our original function fx. So we found that our first function is simply even. Let us try our second function, and this function is fx equal to log x plus x square plus 1. If you think you can tail this question, you can pause this video and try to solve this question. Here, fx equal to log x plus x square plus 1. And we have to find whether it is a odd function or a even function. Okay, so let's start. So put negative sign in place of x. So once we insert negative x in place of x, this function becomes log negative x plus square of negative x becomes x square only. So x square plus 1. Now, in order to simplify this, simply multiply with its conjugate, This can be rewritten as square root of x square plus 1 minus x. Now multiply this with under root x square plus 1 plus x in numerator and denominator. So we get so this is x square plus 1 plus x. Now our numerator becomes, let us use a minus b, a plus b, where a is square root of x square plus 1. So we can rewrite this as x square plus 1, because square of square root of x square plus 1 is simply x square plus 1 minus x square upon our denominator is simply x plus square root of x square plus 1, or we can write square root of x square plus 1 plus x. Now this x square get cancelled and we have log 1 over x plus square root of x square plus 1. We know log a upon b is log a minus log b. So we can write log 1, which is nothing but 0, minus log x plus square root of x square plus 1. Now, since log 1 is 0, so we can write 0 minus log of x plus square root of x square plus 1. And this is our original function. So basically, f of minus x equal to fx. So f of minus x equal to negative fx. So this function is an odd function. Now, let us try the next example. Our third example is fx equal to sin x plus cos x. Sin x plus cos x. So how we know it is odd or even? Simply replace negative x in place of x. So we get sine of negative x plus cos of negative x. You know, cos x is a even function. So cos absorb this negative sign and it becomes cos x. However, sin x itself is an odd function. So sine of minus x is basically minus sin x. We cannot able to write f of minus x since f of minus x is not equal to fx and f of minus x is also not equal to negative of fx. So this function is neither even nor odd function. Let us see our last example, fourth one. Here fx equal to x square minus mod of x. So basically x square and mod of x is simply even function. So difference of two even function itself is a even function. So we can directly say that this function is even. However, if you do replace negative x in place of x, still you get the same result. So mod of negative x is simply mod x and negative x square is simply x square. So f of minus x is fx. So we conclude this is an even function. So in the question list, basically we find this function is even. Our second function is odd. This is also even. And this one is neither even nor odd. So basically, we had done these examples to understand what is odd even function. Hopefully, all of you are able to understand this. However, if there is any problem, then let me know in the comment section. Thank you.